everyone, this video will focus on inscribed angle theorem. So I have here this theorem, the statement of the theorem, but I'll explain it through the equations that we have here. So in this picture that we have here, this red color here is the intercepted arc. So an arc is part of the circles. It's just a portion of it. So that's the arc in red. And then the angle across from this arc is called the inscribed angle. So angle ABC, this corner in blue is the inscribed angle. Now there are relationships that exist between this arc and this angle, and this formula will tell us what the relationships are. So first, the intercepted arc is equal to twice of the inscribed angle. Let's say if this inscribed angle is 10, so then the intercepted arc is 20 because the intercepted arc is twice the inscribed angle. Or the other way around, if we divide both sides by 2 here, we're able to come up with inscribed angle by itself because we're dividing it by 2. So then we can go ahead and say inscribed angle is half of the intercepted arc. So if this intercepted arc is 100, then half of it is 50, and that's the measure of the inscribed angle. So let's have an example to better see how this theorem and how this formula works. So let's take this first example right here. And I wrote the formula that we got from the first slide. I'm going to put that up here so we can go back to it. So let's have this first figure here. So let's say this figure right here. Oops, let me fix this one. So let's look at this figure right here. So we have, we're supposed to determine the measure of, so the letter M here means measure. So we are supposed to measure, we're supposed to determine the measure of RKL. So in this problem, we are looking for the measure of this green arc. So we want that green part right there. So from here, we can go ahead and use any of this equation. But then, since we are given the inscribed angle and we're looking for the arc, we're going to use the first one. So then I go ahead and write the measure of RKL is equal to, again, I'm using the first one because I'm looking for the arc, that is equal to 2 times the measure of the inscribed angle, which is 24. And so if I multiply these two together, that would be 48 degrees. And that's the measure of RKL. And this makes sense because if I put 48 here, 48 is twice of 24, or 24 is half of 48. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we are given the arc, intercepted arc is 216, and we're supposed to get this just like how we did it over here. If I got 48, it's actually half. So this one should be half, but we need to use one of these equations here. Our x is the angle, so we're going to use the second equation, inscribed angle. So our inscribed angle is x. X is equal to, again, that represents the inscribed angle. X is equal to 1/2 of the intercepted arc. The intercepted arc is 216 degrees. So 216 degrees. Half of this is 108. So that's 108 degrees is the measure of angle X. And this makes sense because if I write 108 here, 108 is actually half of 216. Did you get the same answers as this? Good. Perfect. Now let's move on to problems where they come in expressions. So let's take this example right here. So I have this circle, and then this is our intercepted arc. This is our inscribed angle. So how do we solve for x? Again, I'm going to put this equation up here again because we're going to use this in this problem. So you can use any of these, but let's use the first equation. So let's have the first equation. I'm going to show the work down here. So the intercepted arc. So the intercepted arc is this blue part right here. So this is the arc. That's the intercepted arc. And then this is the angle. This is the inscribed angle right here, the one in red. So we are going to use the first equation that we have here. So we can go ahead and say our intercepted arc is the measure of arc FE. So that's from F going to E. That's what we're looking for. And then the symbol for arc is that little arc on top of the two letters. So the measure of arc FE, that's the intercepted arc, is equal to 2 times the measure of the inscribed angle. Inscribed angle is in red. That is angle FGE. So that is FGE. So this corner right here. So then we go ahead and plug values in. So we have the measure of FE is in expression. So that is 6x minus 30 equals 2 times the measure of FEG, the one in red, is 2x plus 25. And then from here, we are going to distribute the 2 to each term inside the parentheses. So this would come out 6x minus 30 equals 4x plus 50. And then we combine like terms. So I'm going to have subtract 4x from both sides minus 4x. So we are left with 2x minus 30. So we can cross this out, equals 50. So then I'm going to add 30 from both sides. So plus 30 and plus 30. So then we are left with 2x equals 80. And then we divide both sides by 2. We divide this by 2 to solve for x. So we're left with x is equal to 40. So our x value is 40. So I can go ahead and say this is 40. Now we want to solve for the measure of FE. Again, this intercepted arc is twice of this inscribed angle. So let's see if that would work. So what are we going to do is we plug in the 40 to this to determine the measure of the arc. So that is 6 parentheses minus 30. We solved the x as 40. So I plug this in here. So that is 6 times 40 is 240 minus 30 is 210. So this length is 210. Now let's solve for the angle, so the inscribed angle. So that would be 2 parentheses plus 25. Again, the x that we solved here was 40, so I plug it in here. So 2 times 40 is 80 plus 25 is 105. And this makes sense because 105 is half of 210. So our FE or arc FE is 210. And our angle FGE is half of it, 105 degrees. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!